Ave Coders, and welcome to this wonderful course on how the object-oriented paradigm works in Python. You'll make yourself familiar with linear inheritance, multiple inheritance, encapsulation, polymorphism, interfaces, and how composition works, as well as abstract classes and methods. I'm going to be using VS Code because, well, I could say that, it's free, convenient, etc., but I just got used to it. Plus, you can add extras to it, which I'll recommend you to do. For example, I'd recommend you to install the Python extension for Visual Studio Code. That should make your life easier and your hair shiny and healthy. Just kidding. All right, so without further ado, let's kick in. We're going to look at some basic principles of OP, and we're going to do that on examples. So I will code some of the examples, some code from scratch in order to illustrate my points. So here I'm creating a class called car, and by convention, the class name in Python should begin with the capital letter. I also use the pass inside of that class, generally specifying that the class is empty, does nothing. So whenever the interpreter will stumble upon that class, it will just pass through it. And down below, I'm creating an instance of that class. So essentially, I'm using class car as the blueprint to create an object of that class. And since the class car is essentially empty, we just cannot leave it empty. We have to fill that void. And so we did it with pass. So car1 does nothing as well. So let's define our first method inside of that class, which will be, of course, init. The init method is essentially a constructor which is responsible for the object initiation. And it has two parameters, self and maker, of which you can see self quite often in the Python code. It basically is a parameter that is a reference to the current instance of a class, and it is used to access variables that belong to that class. And naming self as self is just a convention. And here you can see I'm updating our code. And as you might guess, maker is just the name of whoever makes the car. So BMW or Mercedes. And we have to pass them as arguments. Because this is something that class car expects, and this is something that we need to specify in order to create an instance of that class. And notice that we didn't have to create a new class for BMW and another one for Mercedes. This is the power of using classes. We can have one class but many objects, each of which could be instantiated with a different attribute. So let's print them out. And what we're actually going to see is the address of that object in memory in case of car1 and the maker in case of car2. This is because we specifically called for the maker attribute via the dot operator. If it is a bit too overwhelming for you at the moment, I would recommend you to take my Python for Beginners course via the link in the description. All right, so since we now understand the basic principles of how classes work in Python, let's extend our class car. Let's add model, color, and let's say price. And we also need to add them to the body of this init method. So I'm adding self.model equals model, self.color equals color, and self.price equals price. And now that we have a little bit more in our init method inside of the car class, we'll also need to update the code at the point where we create the instances of that class. I'm talking about car1 and car2. So at the moment we only have maker, so BMW, but we also need to add the rest. And I'm going to generate this as we go. So from the top of my head, we now need to specify the BMW model. So let it be i8. Unfortunately, they've stopped making it, but still. Then we need to specify the color. So let it be white, because white is an absolutely stunning color for i8. And let's say the price, I'll pick some random money, 50,000 of some money to get rid of the floating point. And the same for the Mercedes. Let's say it's going to be anything in C class and will be of a black color. And let's say the price will be equal to 28 and a half thousand money. And if we'll run it again, then nothing will really change. But let's say we want to create some instance method. So I'll go back inside my class and I'll define it as something like getPrice. For instance, I'll pass self and it will return the price. So self.price. So the price of our car. And in here, I can call this instance method via the dot operator. Let's see. Now we have 50,000 of these units printed as expected. And rather than getting something, we can also be setting something. So we can define a new instance method called setDiscount. So let's imagine we decided we'll apply a discount to a certain car. And of course, we'll need to specify the amount. So we write self._discount equals amount. So what does this underscore prefix means in Python? This is to give a hint to other developers that this attribute is internal to the class and should not be accessed from outside of the class's logic. Other object-oriented languages like Java, for instance, it has the mechanism to enforce this logic. But Python basically appeals to developers' consciousness and expects them to stick with the convention. All right, and let's put another piece of logic that will check whether we have this discount specified. So not all instances of the class or objects would have the discount applied to them, or in other words, would have the price modified by the discount. So we're going to use hasAttr function to check whether this attribute is present. And if it's present, we can apply the discount logic to it. So the price minus the product of price and the amount. And if the attribute is not there, then we will return the unmodified price. So I'll move it under the else branch. All right, so now that this is done, let's see this in action. Down below, I will move to where we have our prints, and I will call the setDiscount method on our car2 instance of a class car with the value of 0.25, so 25% discount. And on the next line, I'll print the car2 price with the discount applied. So similar to car1, we call getPrice on car2. But the difference will be that we have set the discount for car2. Therefore, as you can see, the price is displayed with the discount applied. I'll remind you the original price was something like 28,500 of units of money. And here is another mechanic which I'd like to discuss. So for instance, imagine that inside the init method in the car class, I have created a new attribute called secret cog, and it has got the double underscore prefix. And when I do that, Python interpreter will change the name of that attribute. And now any other class that tries to access it will get the error. And this is called name mangling. So let me illustrate the point down below when I'm trying to call the secret cog attribute via the car2 instance of a car class. So let's try to print it, and we should get an error. And the error we get, it reads attribute error, car object has no attribute secret cog, so it can't literally see it. So essentially what it does behind the scenes, it prefixes the name of the attribute with the name of the class. But if I'll precede the name of the attribute with the name of the class, so in this example, I can write something like underscore car, which is a class name, and then double underscore secret cog. Then we can see it goes ch, which must be it's some kind of secret behavior. And speaking about the behavior, since this is a video on object-oriented programming, where classes can inherit states and behavior from their parents, and objects can be created as instances of those classes, I think it will be beneficial if we look into the functions that can help us to define the type of the object. And for that matter, let's create a second class, which we'll call, well, motorbike is kind of a car in a sense. Let's call it boat. So this is completely different from car in any sense. So define the init method. And I don't want to write too much. All I want is to illustrate the point. Therefore, the only attribute it will have is going to be its name. And now that we have our boat class, we are ready to do some manipulations. First, I'll create an instance of that class and I'll call it boat1. So it's going to be an instance of a class boat and it's going to have name Titanic, of course. And below that, let me clear some space. Let me actually get rid of those print statements. All right, and now we can use the function type. So I'll print type. And inside the brackets as an argument, I'll pass car1. And similarly, I'll do the same for the boat one. And as you might have guessed by now, it's going to print the name of the classes, which effectively represent the type for those objects. So car1 is of a type car and boat1 is of a type boat. And now let's see what is going to happen when we'll try to compare, let's say, car2 type and boat1 type using the double equal sign. And of course, since they are instances of different classes and classes represent type, we will get false. You can try to play with it, substitute those objects with other objects, but it is pretty straightforward. What I'd like to do is I'd like to shift our attention to another function called isInstance, which checks whether some object is instance of some class. So for this example, I'll type something like isInstance, and then inside the bracket as an argument, I'll pass the instance under the check and then the class. So if car1 is an instance of class car, then it will return true. And for the second example, I will use boat1 and I'll check whether it is an instance of class boat. So the first two print statements will give us true, while we need to add some false statements just for contradiction. So boat1 is instance of class car and car1 is instance of class boat. Let's comment that out. And the result should be boring and as expected, true, true, false, false. The standalone examples might look a little bit boring, but the function is instance might be very helpful when you trying to do some kind of a check. So if is instance function returns true, we do one thing. If it returns false, we do something else. And as you might have heard in object-oriented languages, everything is an object. Therefore, every object inherits from the grandfather of all objects, object. And of course, it will return true in both cases because indeed car1 and bolt1 inevitably inherit from object. And now let's talk about some other types of methods and attributes. One of them is static, and the other is what's called the class level attributes and methods. So the type of methods and attributes we've been extensively studying so far, it's called instance methods and instance attributes. For example, setDiscount is an instance method and discount is an instance attribute because its value is associated only with an instance that gets created from that class. On the contrary, the class level attributes are shared by all instances of the class. And to solidify your understanding with an example, I've created an attribute called purchase types, which is a tuple where we essentially specify how you can buy our car. And currently you can do that with lease or cash. And let's imagine that we need some kind of a method that will return those purchase types. And as you might have guessed by now, it will be a class method. Therefore, I'll use a decorator that will specify that this is a class method. And because it works on the class instance, not an object instance, I'll need to pass something I will define as CLS, as for class, instead of self. Therefore, in return statement, I write CLS dot purchase types. If you want to learn more about these conventions, you can refer to the document called PEP8. Of course, I could have left the link in description, but I was told that something called Google was invented recently that allows you to search and eventually find anything. And we also need to add those purchase types to our init function. Let's assume that our car dealer is very conservative, and since we only have two purchase types, which is lease and cash, but there are more of them out there in the wild. I've heard that some car companies even accept crypto. Therefore, we can do a little check down below. So if the purchase type is not in this tuple, purchase types, then it will raise a value error. And inside this value error, we can put some polite statement saying that the purchase type that you have offered is not basically valid, so we cannot accept it. So it is not a valid purchase type. However, if the purchase type that the instance of the class car will be instantiated with is present in the tuple, then we'll say self-purchase type. So else self-purchase type. In other words, it is valid and we accept it. All right, and now that we added this class attribute and class method, we'll need to expand our car1 and car2. We need to add them, but first let me comment out the print statements. And now let's add these purchase types to car1 and car2. Let's say for car1 it's going to be cash, and for car2 it's going to be lease. And let's write some print statements. We'll begin with the generic. I'll comment that out. We don't need the boat. So we'll begin with a generic print statement that will essentially print what purchase types do we have in our class. So I'll type purchase types, colon, and then will be car dot get purchase types. This is just a simple check in case we'll run into a problem. So we have lease and cash. All right, as expected. And now we'll print the purchase types for car 1 and car 2. So I'll go for car 1 and car 2. And same as we did before with instance methods. So we have car object, and this is the location in memory. This is all good. And now we can use the dot operator to access the purchase type. And let's see, we have cash and lease. Brilliant. And now let's see what's going to happen if we will use some purchase type that is not existent in our class. Something like swap, for instance. Then we get a value error. Swap is not a valid purchase type. So we get the expected behavior. All right, now let's have a look how static methods work in Python. Here's a little bit simplistic explanation that static methods earned their name, static, because they don't really modify the state of class or specific object instance. And we'll see how they work in just a second, but let's do some preparations for this example first. So let's define an attribute called sales list, which is prefixed with double underscores, which essentially make it a private variable, and we'll initialize it to none. And then we'll define a static method that will expose this sales list to the consumers of the class car. And similar to the class method, to make the method static in Python, you essentially write a decorator static method. So this static method will return the sales list. So if car sales list is none, it will create one. Otherwise, it will just return the sales list. So basically what we're trying to do here is to implement a singleton design pattern, which basically ensures that only one instance of an object or a variable ever gets created. And this get sales list static method can essentially help us to add sales to our sales list. So if we defined a sales this month variable here, and we can use the dot operator to get sales list. And on the next line, I can write something like, well, print it first, print sales this month. And we have value error. This is because of that swap. Let's change it back to lease. And we'll try to run it again. And now you can see we have an empty list. So on the next line after the sales this month, we can write something like sales this month dot append. And as an argument, we'll pass, say, car 1. And similarly, the next line going to append car 2. And as you can see, we have now a list with two objects, car 1 and car 2. I hope that is clear because we need to move on. And the next subject will be the inheritance. And let me briefly remind you what inheritance is. All right, so let's imagine we have a class. The class has attributes and methods that define its state and behavior. And let's imagine we decide to create another class, but rather than define states and behavior from scratch, we say something like, let this new class be inheriting the state and behavior from the first class we created early on. In that case, the former will be called a parent class and the latter will be called a child class. The relationships between them will be defined as is a relationship. So class 1 is a parent of class 2, or class 2 is a child of class 1. So for our example, let's define another class, called car. And I've copied the init method from our previous example. I'll just take this purchase thing off, and let's define another class, and we'll call it forklift. So of course this class will need init method as well. So the way init method looks at the moment is not the way we want it, thanks to the autocomplete in VS Code. So we need to modify it. We want maker, model, color, and price. And we're going to add another parameter, which is lifting weight. Well, because it's a forklift. And we'll need to fill the body of that method as well. I'll just copy that over and I'll add the lifting weight. So these are two classes that we will work with. We will expand on that topic. And let's copy the whole of the forklift class and paste it down below. So we'll define another class, say that's going to be called crane, and I mean auto crane. And what's important is that those two classes, say forklift and crane, as in auto crane sense, they are both, some sort of a vehicles. So they all have maker, model, color, price, and they can lift some weight. You can basically notice two things. First is that class car is not much different from forklift and crane. In fact, it is the same class but without the lifting weight attribute, and that there are plenty of attributes just being repeated. And as you probably know, repeating the same code is not a very good idea. So first of all, let's deal with the first issue and add a new attribute to the init method, which is going to be the number of seats. Therefore, we will at least have one unique attribute for the car. And in order to address the second issue, we can use the inheritance. So first of all, let's define a new class called vehicle that will be, say, a parent of all classes, car, forklift, and crane. Let's define init method. Thanks for the autocomplete. Basically, we'll just copy and paste that from class car. So I will define the same stuff, self, maker, model, color, and price. And I will copy and paste the rest. All right, so now we have these attributes in class vehicle, and we don't really need them in class car. So as I've said, we don't really want to repeat ourselves, repeat the code. Therefore, we can use the inheritance mechanism in order to address that. So let me get rid of all these attributes, and instead we will type the following. To sort of point to the parent class the class will inherit from, we use the keyword super, so that vehicle is the super class of class car. Here we're basically saying that we will inherit the init method from the class vehicle. In other words, we'll just copy the attributes of init method from our parent class. Once again, this construction allows us to say that the maker, model, color, and price will be copied directly from our parent class, vehicle, and we need to put vehicle inside the brackets as well in the car class to specify that this is our parent class. And also, car class will have its own attribute which is not present in its parent class, called the seats, which corresponds to the number of seats. And let's create another class. We'll call it something like industrial vehicles. And this will be a parent class of forklift and crane. So essentially, we're going to have the following schema. Class vehicle is the parent class of all classes present in this file. Then class car inherits directly from class vehicle. Class industrial vehicle inherits directly from vehicle as well. And forklift and crane will inherit from industrial vehicle, and therefore the vehicle itself is going to be like the parent of its parent, if you like. So once again, we have a lot of redundant code. Therefore, we can use the inheritance mechanism once again. The forklift and crane will be inheriting from industrial vehicle. Therefore, they can use all of its attributes. And now that I've specified that forklift and crane inherits from industrial vehicle and that industrial vehicle inherits from vehicle, I can get rid of that redundant code. So let's start with the industrial vehicle first. So they can be replaced by super and pointer, if you'd like, to the init method of the parent class. And we need to copy them into the init method as well. All right, so now the only unique attribute we've got left is the lifting weight, which is defined first in the industrial vehicle. And now we'll do the same with forklift. So we're going to replace all those attributes with a super, but this super will be pointing at the industrial vehicle. So the class it is inheriting directly from. And we'll do the same for the crane. I will just copy and paste forklifts init methods into crane, and that shall do the trick. So once again, class car inherits from vehicle, class industrial vehicle inherits from vehicle, and forklift and crane inherit from industrial vehicle. All right, we are ready to create the instances of these classes and see how they work together. All right, so our first object will be called car1. It will be an instance of the car class, and as the maker, I'll come up with something like Opal, and as the model, Mocha, and color black, and the price will be an integer, so we won't need the quotes. Let me get rid of them. So 20,000 units of money of some sort. All right, so let's do another one. Forklift. So forklift 1 is an instance of the class forklift. Once again, the maker, I'm not sure, Honda, I think they do forklifts. Model, I definitely have to look it up, or just make something up. It doesn't matter. It's like a placeholder value. We need to illustrate the point. So the color will be brown, and money the price will be 15,000. Next one is crane 1, and it's going to be an instance of a class crane, of course. And who makes cranes? Caterpillar. And the model, let's say this, and then the color, of course, yellow, and it's going to have some hefty price. All right. We also forgot about another attribute, the weight it can lift. So let's say it's going to be in tons, and for the forklift it's going to be 5, and for the crane it's going to be 55. Very nice. 55 might be a little bit too much, so let's make it 15 because it's an auto crane. And now let's try to print them out. So the first print statement, car 1, the other one forklift 1, and the last one will be crane 1. I'll explain in a second why we put them in a separate print statements, because basically if we're going to launch the program execution now, we're going to be given just the address in a memory for this object, but we want to print some attributes. Therefore, we're going to use the dot operator to access those attributes. So you're going to have car1 maker, car1 model, car1 color, car1 price, and we also need seats. I forgot the seats, so car1 seats. I'll speed up in here so you won't be too bored me typing. So we're almost done. And let's try to launch it. And we run into an error, attribute error. Crane object has no attribute maker. This is because I've done the copy paste and I've probably missed a bit of code. So let me correct that. Let me copy and paste that again. All right, that will do. Yes, you can now see how by utilizing the inheritance mechanism, we have reused a lot of code. Otherwise, that will be redundant. But there was one slight problem. Nothing would have stopped us if we would want to create an instance of a class vehicle or industrial vehicle. Nevertheless, they are more or less abstractions. So conceptually, they are more of a blueprint from which we create cars and forklifts and whatnot. So there is a programming concept called the abstract class. So the class, which is surprise, surprise, abstract, and we cannot create a direct instance of that abstract class. So let me show you how this concept works in Python. So here we create a class called electrical appliance, and it's going to have init method, of course. I'll just get rid of this autocomplete, and we'll immediately define that it inherits from some other class. It may not be apparent which class it inherits from or why we need to do that straight away, but it will make itself clear once we define other classes and methods. So we write something like super.init. And let's say down below we'll define another method, which is something that is common among all electrical appliances, something like, I don't know, power. Well, maybe not power, but let's say electrical consumption. So all electrical appliances will have their own rate of electrical consumption. And for now, we'll leave it empty. The idea is that the classes will define below, let's say class heater, that will be inheriting from electrical appliances. So these classes will need to implement this method by themselves according to the idea behind their classes. So one of the classes is called heater, so it will be, well, heating. So I need to specify this attribute, heating, and I need to add it here as well. All right, that's done. And the next class will be called cooler. and it will inherit from the electrical appliance class as well. And instead of heating, it will be, surprise, surprise, cooling. So we'll specify it here. We need to also specify that it inherits from the electrical appliance class. So that's cooling. We'll get rid of this boilerplate code. That here. All right. As you can see, the electricity consumption method is not implemented in any of the classes that inherit from electrical appliance. And we can happily get away with that because there is no mechanics that could force us to implement this method at the moment. And also, nothing prevents us from creating an instance of the electrical appliance class. Nevertheless, conceptually, it is an abstraction. So in here, we'll create an instance of a class heater and instance of a class cooler. And up here, we'll define, here is instance of a class electrical appliance, the instance of our abstraction class. Of course, we need to specify an attribute. In case of the heater, it will be some heating units, so probably degrees, 50 units of temperature, and cooler is 20 units of temperature, and then we'll print them out. Despite that, it will only give us the addresses of these objects in the memory. We just wanted to prove the point that nothing prevents us from running the code as is. So in order to enforce this mechanic that the electrical appliance class is an abstract class and we cannot create a direct instance of this class, and electricity consumption is an abstract method and we need to implement it, we will import something from the standard library, the module called ABC, so abstract base class, which will basically allow us to enforce this mechanic. So from ABC, we import ABC and abstract method. And now in the electrical appliance class, we put that it inherits from the abstract base class. And now this super statement makes sense. Same for the electricity consumption, put self and abstract method. And if we'll run the code now, we're going to get into an error. So can't instantiate abstract class. So we need to get rid of that E, instance of the electrical appliance class. And we also must implement this electricity consumption method. So let's deal with it first. So in class heater, I'm defining the electricity consumption. And let's make sure it's doing something useful. So when we create an instance of the heater or cooler class, we pass a value. In case of heater, it's 50. So let's assume that to heat a room for 1 degree, this heater consumes 1,500 of units of something, maybe power or something else. And we will multiply this by the value that is being passed when we create an instance of that class. So in this case, by 50. I'm not trying to do something meaningful here. I'm just trying to prove the concept, abstract classes and methods in this case. So let me jump to the cooler and implement that method before I forget. So you will multiply, let's say, the consumption equals to, I don't know, 300, and it will multiply it by the value that is passed when we create an instance of a cooler. So we multiply it by the attribute cooling. And self. I need to get back to the heater and we'll multiply it by self.heating. All right, so at least it is shaping into something meaningful, and we can even try to run the code. So we have heater, we have cooler. Let's try to run it. And we run into another error immediately, which is basically the same error. I just forgot to remove the creation of the instance of an abstract class. So we need to comment that out. As you can see, no errors. But what if we would like not the addresses in memory, but the actual heating and cooling values? So we need to use the dot operator, and we do h dot, and what we need is heating, and case of cooler is cooling. And let's also utilize the method electricity consumption. So it's going to print the electricity consumption for the heater and for the cooler. And of course, because this is a method, not an attribute, we need the brackets. Okay, so we have the value for the heater, and then this value get multiplied by 1,000, and we get the electricity consumption. Same mechanics works for the cooler. Okay, so this was a brief overview of how the abstract classes and abstract methods work in Python. Next, we'll look into the multiple inheritance. So the inheritance we looked at so far sometimes is referred to as the linear inheritance, is basically where we had a class vehicle, then it was inherited by class industrial vehicle, and then it was inherited by forklift and the other one, the crane. But this is sort of one line of inheritance. Multiple inheritance is when we have several classes at the same level and another class that inherits from both of them. Multiple inheritance is not allowed in some languages like Java, but Python is not the case. In our example, a class called child will inherit traits from both classes parent1 and parent2. So let's say parent1 will have an attribute smart and parent2 will have an attribute pretty. So let me sort all that. So the multiple inheritance is not tremendously complicated concept to understand, and as I've mentioned before, it's not quite natural for other languages like Java, for example, which forbids multiple inheritance completely. But here in Python, it works pretty well. So we define two classes, parent1 and parent2, with two distinct traits for smart and pretty, and class child inherits from both parent1 and parent2. Therefore, it does not need to define those traits, those attributes inside the child class. It can only do effectively pointers to its parent classes. So if I'll print the self.pretty and self.smart, it will pull the values for them from the parent classes it inherits from. And down below, I'll create an instance of the class child, and then I will access the traits. So I'll do that via the dot operator, child.traits, and we'll, of course, need to print that pretty and smart. Right, so it works nicely, but what if we have not distinct traits or distinct attributes, but what if both parent classes contain the attribute with the same name? So which one gets inherited? Let's say, for example, that the parent one has got an attribute hair color, and it will contain the value, let's say, light, and parent 2 will have a dark hair color. In this case, both parents have an attribute with the same name, but different values. So child will inherit hair color as well, but the question is which one? And this is where something called the method resolution order comes into play. So here we specify the order of inheritance as parent 1, then parent 2. So parent 1 has light hair color, therefore it gets inherited by the child. Well, if we'll swap them around, let's say parent 2 will get the prevalence over parent 1 in the inheritance order, then the child will inherit whatever parent 2 has got as an attribute value. So in this case, it's going to be hair color equals dark. So let me illustrate that by just swapping them around. So I'll select parent 1 in the child class. I'll cut it and I'll paste it behind parent 2. Of course, don't forget the comma. All right, and now let's see the result. In this case, parent 2 was given the top priority over parent 1. So now you can see the hair color has got value dark. As I've mentioned, it's not a terribly complicated concept. So the next concept we're going to look at is how we define interfaces in Python. So just as a reminder, at a high level, an interface acts like a blueprint for designing classes. They are somewhat similar to the abstract classes, but with a key difference that in interface, you only define the method, you cannot implement it. So the class that inherits or rather extends the interface will need to implement that method. I would highly recommend to look up the definition in the docs. All right, so here, as you can see, we define a class called shipping, which inherits from the abstract base class. So the interfaces are in a sense resolved via the abstraction, and we defined a method inside of that abstract class and use a decorator to mark it as abstract method. And here down below in heater class, we can define under the method shipping. So the heater class will extend the interface shipping and will need to implement the method from the interface. You can get this code from the Ave Coders repository. I'll leave the link in the description below. So the class heater has implemented the method from the interface shipping. And in here, as you can see, where we create the instance of the class heater, we need to specify the shipping type as well. So in this case, I'll use the cargo ship. And we finally got the updated result. Once again, not too complicated concept as well. All right, let's have a look at the composition. In order to understand composition, we need to look back at the inheritance schema we had with our cars. So car was inheriting from vehicle, and forklift and crane were inheriting from industrial vehicle, which in turn inherited from the vehicle. And basically, these were is a relationships. So car is a vehicle, crane is an industrial vehicle, and industrial vehicle is a vehicle. Composition, which we'll look at in a second, has got a different type of relationship, which is called has a relationship. So this is where a complex component might consist of different simple components. As if your car, for example, has an engine, it has a steering wheel, or it has wheels, and so on and so forth. And wheels, engine, steering wheel is an object by itself. So composition here, I will describe it with the music band example. So music band is basically a group of people and a brand, and musician is a different object. In this case, music band consists of musicians. So let's see that in code. We will code the composition example from scratch. So I will be creating the classes and objects as we go. So there might be some blips and errors and repetitions. Please forgive me for that in advance, but this is what live coding looks like. So class music band, it has got the init method, of course, and let's say it has, so let's create this super class first. Not really good name, but class that has a lot of attributes that can be later delegated to other classes. So name, label, and musician. And of course, we'll need to define that in the body of that method. So self name, self label, and self musician. Nearly there. All right, done. Okay, so this is a good start. However, we need to add some more attributes. I should say, especially if we'll later delegate these attributes to a different class. So, for example, musician without an instrument is not really a musician, is one thing. So, we'll need to add instrument as well. And we'll put it here. So, instrument. And we'll specify that in the body as well. So, instrument, self.instrument equals instrument. And also just think of it, when we create a class music band, when we create an instance of that class, we will end up with a single musician. So we'll need something else. We'll need some kind of a list with musicians. Otherwise, we'll end up just with a single musician. And we'll also need some kind of a method to put these musicians to that list. So let's call it hire musician. So it's going to take self, name, and instrument. And we'll start to reshape our classes. So first we'll define self musician. Actually, there's a wrong indentation. So self musicians dot append. So this is how we're going to put musicians into our list. And of course, name and instrument. So we can even conceptually see that we're going to be better off if we'll just separate these entities, such as musician and music band. So we'll leave class music band and we'll create another class and call it musician. Let's define the attributes, and later we will take them away from the music band class. So inside of init, we'll write name and instrument, and equally self.name equals name, self.instrument equals instrument. All right, that's all done. And now let's try to make it more visible. Let's say when we create an instance of a class musician, it will immediately tell us what kind of musician it is. So what is musician's name and what instrument does he or she plays. So in order to do that, I'm going to use the format as string. If you're not quite grasping what I'm saying here, you can definitely check out my video Python for the beginners. It's a great 2-hour tutorial which is available for free on this channel. All right, so This string representation method is called the magic method, and subscribe to this channel so you won't miss the tutorial on them. All right, now let's go ahead and remove the attributes we already transferred to our musician class. And we also want a music band class to take the musician object as an argument. So all we need to do is just to modify the argument list slightly. So musician equals none. And we need to add it here. And I also want to modify the whole musician's approach. So I don't want that to be name anymore. I want it to be separate, so we can separate words, so we can avoid the confusion. Title may not be the best word to choose, but we want to sort of separate the name in musician and the name in music band. And now the hire musician, well, we can change that method as well. And let's say we want to write albums instead of hire musicians. So I'm making it up as we go. You might want to refactor my code later as your homework if you want to, but here we go. We have a method called write album, which has song and genre, and we're going to specify another list which we will call album. Presumably it will reflect albums that the music band can write. I'll get rid of hire musicians. Okay, we're going to need to rewrite that as well. Self album to append, and of course song and genre. This looks much better now. And down below we will create another class which we'll call album. And as you may guess, it will have song and genre. So def init self.song and genre, and similar here. It might not look as as professional, but I just wanted to prove the point and show you how the composition really works in Python. So in essence, we split the music band into other classes responsible for their own stuff, like musician and album. And this method, write album, no longer takes song and genre. It will take album. And we'll see whether it works or not, which sounds promising, I know. And I think our classes now look pretty neat, so we can crack on with creating their instances. So band1 is an instance of music band class. Let's give them a title, the Beatles, and label. I think their label was parlophone. Correct me in comments if I'm wrong. And musician. We can of course create another instance of class musician and do stuff there, but I'm a bit tired by now. I'll just specify it as a string, Beatles. Like I said, as a homework, you can refactor the code and correct all wronggoings in here. So the album, first album is White Album, then we can go for, let's say, Hard Day's Night. And the last one, Help. And of course, after we created the instance of the class and potentially filled it up with albums, we can print the results. So let's say band1 title, then label, and musician. Other way around, but it doesn't matter. And we also want to print the album, so that is the list of albums. So let's see, the Beatles, Parlophone, White Album, Hard Day's Night, Help. All right, so despite there is plenty of room for improvement in this code and in other of my examples, this illustrates how composition works. So you can actually delegate pieces of your class into other classes so that it will be a composite class. It will be composed from other more simpler classes. That was V. Please give this video Emperor's thumbs up, toll the bell, and subscribe. And I'll see you in the next lesson. Bye for now.